Okay, so in today's experiment, we're going to be looking at experiment 20, the Aldol reaction to generate dibenzyl acetone. So we have set up already our 3 milliliter conical vial with a spin vane, an air condenser with a septa on top, and we have O-rings throughout. What we are going to do, just to give everyone a view before we add our reagents, is we are going to add the benzaldehyde and acetone, and then in turn we are going to add a ethanolic sodium hydroxide mixture. This will in turn initiate the aldol reaction. We are going to have our flask initially cooled at 0 degrees Celsius, and then once the reagents are mixed, we're going to allow the reactants to mix at room temperature for 30 minutes. I'm showing you this because the sequence has to be done relatively quickly, and you will see the final mixture back at the station when we resume the recording. Okay, so we have our reaction mixture in our ice bath. I'm going to take it over to the station and add our reagents. Okay. So we've combined our reagents. So we've combined our benzaldehyde, our acetone, and our ethanolic sodium hydroxide, which is our base catalyst. And you're already seeing that the solution is beginning to exhibit a characteristic yellow color. This is great to see, as that indicates that a reaction is beginning to take place and we're starting to generate our dibenzyl acetone. So we're going to allow this mixture to stir at room temperature for 30 minutes. And in the meantime, we're going to prepare a filtration setup. So we have off to the side, prepared and ready for use. We have our filtration set up. We're going to collect the product via filtration, and then we're going to purify it using a Craig tube via recrystallization. So we're purifying our product via recrystallization before we take an IR, NMR, and do some chemical tests. So we'll let this mixture stir for 30 minutes, and then we'll resume once the reaction is complete. Okay, so as it has been 30 minutes and our reaction has completed, we're going to isolate our yellow dibenzyl acetone product, which is the aldol product after elimination. And we're going to transfer it and isolate our product via filtration in our Hirsch funnel setup. So let's move over to that. So we have our Hirsch funnel set up, and what we're going to do is we're going to very carefully filter our solid yellow precipitate dibenzyl acetone, and then finally once we've isolated our crude material, we'll purify it via recrystallization. Okay, so we have our Hirsch funnel loaded with our filter paper. Now you may ask, why are we filtering our sample if we're going to recrystallize it? Well, the point of this filtration is to ensure that we've completely removed the sodium hydroxide from our mixture. If sodium hydroxide is present, it's going to really make the purification step troublesome. So we're going to pull vacuum, and we're going to begin to filter our sample. So now what we're going to do is we're going to sequentially rinse our mixture with 1 milliliter aliquots of deionized water. This is designed to remove any sodium hydroxide from our solid cake and transfer it into the filtrate. We want to make sure we get rid of all the sodium hydroxide. Otherwise, our purification step is going to be quite troublesome. We're also going to remove and wash off now. In addition, when we're washing off our spin vane, so we've plucked it out using our forceps, and now what we're going to do is we're going to carefully scrape off any solid residue. We want to make sure to scrape off as much as we can, so that way we maximize our isolated product yield. Now, we'll resume once we've completed this transfer process. Okay, so now we're going to continue to rinse our mixture with aliquots of water. The goal of these rinsing steps is not only to assist in the transfer of solid, but also to ensure that our filter cake solid is free of sodium hydroxide. So after we've completed multiple rinses, we see we have isolated a reasonable amount of this nice yellow solid. What we're going to do is we're going to allow this solid to air dry for 10 minutes, and then we'll recrystallize and purify our solid via recrystallization and trituration. Okay, so our solid has finished drying. So now what we're going to do is we're going to move over to our next station. We have our Craig tube set up. So what we're going to do is we're going to load our Craig tube with the solid. So we're going to transfer our solid over. So we're going to carefully transfer our solid into the Craig tube. I want to make sure that the Craig tube is held secure so it can't move. Okay, and now we're going to transfer our solid carefully into the Craig tube. and we'll resume once this transfer has completed. Okay, so we've transferred all of our solid to the Craig tube, and now what we're going to do is we're going to carefully triturate with absolute ethanol. So we're going to add just enough to begin to generate a suspension. Okay. So we want a nice suspension for the recrystallization. So that way we can first sort of suspend our solid and then dissolve any potential impurities. So now we're going to agitate this mixture. Okay. And we're going to continue to agitate this mixture to try to draw as much of to break up our product solid and to try to draw and dissolve any impurities present. You can also break out your spatula and use that too. So we're triturating, we're agitating our solid in the presence of the solvent, and that in turn is going to break up our solid and dissolve any potential impurities. Okay, so now what we're going to do is we're going to load our Craig tube and we're going to separate the precipitate that we've washed from our solid. So we're going to load our Craig tube cap. This cap is where our solid's going to collect on. We're going to load it into our centrifuge tube, and then we're going to carefully invert. So we now have our complete Craig tube setup. We have our dummy tube setup. It's going to serve as the counterbalance in the centrifuge. And now what we're going to do is we're going to centrifuge our mixture to separate our solid precipitate from the filtrate liquid that contains potential impurities. So we're centrifuging our mixture to separate the solid from the liquid, and then we'll collect the solid and weigh the purified solid. So as you can see, we've separated our solid from the filtrate, and now what we're going to do is we're going to carefully scrape off our solid onto a piece of tarred filter paper. So we'll save the filtrate liquid. And now what we're going to do is we're going to carefully scrape off our solid. We're also going to transfer the solid remaining in our Craig tube. And we'll resume once we've completed this transfer process. So we've completed our transfer and we've isolated our solid. Let's now weigh out our purified solid mass. So I would like you now to record the isolated mass of dibenzyl acetone that we are able to isolate at the end of the reaction. So as before, we're going to take an IR spectra in NuJoule. We're already taking an NMR spectra in deuterated chloroform. So let's keep going and let's collect an IR spectra to fully characterize our compound. So the first thing that we're going to do is we're going to take a small amount of our solid and we are going to mill it and we want a nice fine powder. Okay, so now what we're going to do is we're going to add our NuJoule. So we're going to add a few drops of NuJoule and then mill our solid into the NuJoule mixture. Remember not to dip the spotting stick into your solid or you will contaminate the entire batch of NuJoule mineral oil and then all your IRs would be showing the presence of an impurity. Okay, so now we're going to mill our solid into the NuJoule. Okay, and now we have our plates and we're going to carefully spot and then we'll push the two plates together and we're ready to take an IR spectra. So we're going to load this plate directly into our spectra, into the IR spectrometer, and we'll record the IR spectra for our dibenzyl acetone. Okay, we're now going to do a series of chemical tests in the spot plate. So the first test, which is going to be on the leftmost side, we're going to do the 2,4-dinitrophenyl test. So what we're going to do is we're going to add 7 to 8 drops of 2,4-dinitrophenyl to our solid. Okay, and now we're going to mix We're then going to check for the formation and generation of a red to yellow precipitate. And as we notice after mixing, there's been a pretty dramatic color change, and we now see and we now can observe that we have inside our reaction mixture a red precipitate. We're going to isolate this precipitate and take the melting point as further verification that we've generated the dinitrophenyl hydrazine derivative. So as part of our test to verify the presence of an alkene, we're going to subject our compound to the Bayer test. So in the Bayer test, what we are first going to do is we're going to dissolve our compound. We're going to dissolve our compound in half a milliliter of alcohol-free acetone. Okay, so our compound's now dissolved. And now what we're going to do is we're going to add 2 to 3 drops of potassium permanganate, and you should look for the formation of purple permanganate and brown manganese oxide. That would be a positive test. 2. So as we notice, we see a discharge of purple permanganate color from the reagent, and if we mix this, we can notice the brown manganese oxide products forming as well. So this serves as a positive test for the Bayer test, which indicates that we have an alkene present in our molecule. So we can really see the manganese oxide formed now after a little bit of time has elapsed. Okay, so we're just about ready to run Tollen's test. So in this case, we have our Tollen's reagent prepared. We're then going to add our solid. And what we're going to do now is we're going to carefully agitate the mixture. We're then going to let this mixture stand at room temperature for 10 minutes and monitor our results. So for our last test, we'll be doing an ignition test on our compound. We should see a sooty flame if we have an aromatic ring. So we're going to take our solid and subject it to combustion, or more specifically ignition. Let me do another run, just so that way it's a little bit easier to see. Okay, so as we notice, we observed a relatively sooty flame, which indicates the presence of an aromatic functionality. So, from all the information provided from the chemical tests, you have enough information to complete your laboratory report. To check back on our silver nitrate test, We do not see any characteristic formation of the silver mirror in our mixture. So in turn, we can conclude that we do not have an aldehyde present. Our benzaldehyde completely reacted. So from this information and the data provided in the lab manual, as well as the supplemental melting point data provided on Canvas, you will have enough information to complete your lab report. Again, this concludes the synthesis. This concludes our synthesis of dibenzyl acetone.